Okay. Well, thank you for turning up. This session this afternoon is going to be on exploring some of the Tetration APIs. So I've seen you before. You're from Cisco, so you probably know a little bit about Tetration, do you? Okay, cool. And how's your knowledge level on Tetration? Okay. So we have like 2 slides to talk about what Tetration is, and then we'll spend the rest of the time actually doing some programming. So I think if everyone here has seen some of the demonstrations on Tetration before, this is going to be a very simple description, but Tetration is taking in telemetry data, so information from software agents that sit in the operating system, from switches, from flow logs in your cloud providers, from load balancers, and passing all that information and storing it to, hit on a couple of different use cases. There's many other sessions that talk about the Tetration use cases, but what we're going to be focusing on mostly today is this insights section and the segmentation section, and how we can use APIs to programmatically drive the policy that's being enforced in Tetration, and then how we can use the message bus, Kafka, to look at the policy that has been enforced in Tetration and get the latest dynamic updates as and when the policy is changed. So we're going to spend maybe 15-20 minutes doing some Python programming using the REST APIs, and then another 15-20 minutes doing some programming in Go using the Kafka stream and the protobuf. So you saw this, we've spoken about this in a couple of different sessions, but when it comes to a big data platform, there's a couple of ways that you can access and manipulate the data, and not all types of data are created equal. If you think about pushing configuration, that is more often a user-initiated kind of action where a push API like a REST API would make sense to interact with. However, if I want to be notified dynamically when there is an update to my policy or there's been some change to my enforcement status, I really want an event that comes as soon as that has happened, rather than having to do a pull or a poll every 30 seconds. It's a much more efficient way. And then finally, if you're looking to actually manipulate the data that Tetration has stored, then it might make more sense to actually run code directly on the Tetration appliance, and that's using Tetration applications. So what we're going to be focusing on today in this session is mostly the REST API part. So that's the bit that I'll be looking at, and then the Kafka piece, Remy's going to be joining me up on stage later to look at how the Kafka broker works in Tetration. So what we're going to use in the REST API, so the REST API has a lot of use cases that you can cover, and I'm going to show you some of the documentation. I wish that we could hit every single API today, but then that wouldn't really make sense. So we're going to focus on the application policy part of the API today. So who's allowed to speak to whom, how we group them together, and what policies have been pushed down. And then in the Kafka part, we're going to be focusing on the policy that comes out of Kafka in a protobuf format. So without further ado, let's jump into our application today. So what I'm looking at right now is a Tetration application workspace. So this is where we have a really simple policy at the moment, where we have a tenant called Brewing Co., because it's Cisco Live, and obviously it has to be related to beer in some way. And we're allowing port 80 inside that tenant. So all of the different workloads are allowed to speak to port 80. But everything else is going to be denied. And in this example, what we're trying to do is allow the servers inside my data center to speak to Google DNS and no one else. So we need to do a couple of things to achieve that goal. Firstly, we need to create an object to identify the Google DNS service, so which IPs make up that service, and we're going to use an API call to do that. And then we need to add an extra row to this table that's going to describe exactly which clients are allowed to access that Google DNS server and over which ports. And then finally, right now, we are not enforcing any policy. So, the policy is in a simulation mode and we haven't made any changes to the workloads, and we want to programmatically enable that policy enforcement on the devices and push down the firewall rules into the OS host firewall. So that's what we're going to do. Make sense? Now, Tetration has a lot of documentation on the platform itself. So I'm going to jump back and forth between the documentation, using the examples from the documentation, crafting them into our specific use case. If you do have access to Tetration, or you go and do any of the labs and you take a look at this, there is a huge list of APIs, really pretty well documented. It's not just a dump of the APIs, it's actually got nice descriptions as to exactly how you would use those particular endpoints. So the one that we're going to be focusing on today is applications and security policies, and also the inventory filters. So the inventory filters is the first part of our application. We need to select the IPs that match the Google DNS service and create an object to refer to them. So for our application, we're going to be using the Tetration Python client. So it's called the TetPy client. It's open source, we keep it up to date, and we publish new versions of that. And that's supported by the Cisco engineering group. So how does that look at the back? Can everyone read that? One more? You good? Or you can come closer. There's two ways to solve this problem. So I'm going to install my Python client, which I actually already have done. That's all I need to do to allow me to get access to the API, or at least have the client to access the API. And the other thing I need to do is generate myself a set of API keys. So for my tenant, I need to come over here to my API keys. I'm going to generate an API key for our DevNet session. That 172. And Tetration's API keys have a certain set of roles that you can assign to them. So, in best practices, I'm not going to assign every single role, because this application only needs to be able to access security policies and enforcement. I don't want it to be able to, manage the software sensor or the hardware sensor on my switches. So I'm going to select flow and inventory search and application and policy management. That should be enough for what I want to do today. So I'm going to create that. It's going to give me an API key, which I'm going to paste here, and an API secret, which I'll paste here. You'll never see this secret again, so do make sure to write it down if you're ever doing this yourself. I lose them all the time. I keep generating keys over and over when I forget to copy and paste it, or I lose the file. And so we have our kind of shell of an application here. Right now it's empty, just has a couple of comments. We want to connect to the Tetration cluster, and then we're going to do a couple of steps, which is creating the filter to extract the DNS service, add that policy, add the ports to the policy, and then enable policy enforcement. So the first thing that I really want to do is get connected to my Tetration cluster. So we have this API credentials file in the directory, so we're going to read that credentials file, and then we're going to create a REST client instance. So the REST client is the client provided by that TetPy client library. You can see that if I mouse over it, it's going to give me some descriptions about exactly how I use this. But it's actually pretty lightweight to use the REST client. It's really just a thin wrapper around the REST API, so it does provide the authentication. Everything else is just giving you basically raw access to be able to post and get queries to the API. So I'm going to get myself a REST client. And let's just double check that. So I just called my file, and we've not had any errors, which means we're connected to the Tetration API, and we can start making API calls. So The first thing that we want to do is create the Google DNS filter. So the filter is going to be part of my application policy. So my application policy says, who is the consuming entity, which IPs are allowed to be the source IPs, and which IPs are going to be the providing IPs. So, I could say, having nice Wi-Fi connectivity issues. What we're attempting to do basically is this, which is create a filter with the name Google DNS, and I want the query to be address equals 88888. So that's what we could do in the UI, and we're going to try replicate doing the same thing with the REST API. So if we come back to our inventory filter documentation, to create an inventory filter, I just can take this little snippet of code and copy and paste that in. So it's going to need an app scope ID, which is referring to who owns this filter and who's allowed to modify and use that filter. So luckily, I've already saved that ID in a different one over here, so that we don't have to keep remembering that. And I'm going to call the filter Google DNS DevNet 1722. So we can define a query. The query can get pretty complicated, and you can nest different dictionaries in there, so you could use ors and ands until you come up with a pretty complex way to select that object. But seeing as that's not really the point of this session, we're going to do a really, really simple Google DNS is equal to the IP 88888. It's not even actually, there's 8844 as well, so we're not even capturing everything. But that's all I need to do to create that filter. And I'm going to check that the filter is OK. And if it's OK, I'm going to get the filter. It's going to be the response ID. And we will say so hopefully, if I typed everything correctly, we have created a filter called Google DNS. And it's been assigned a new ID, which is 5C51. So just to prove that that really did happen, we probably now can see if it's a little bit slow, but we can see that we were testing earlier, so we have quite a few of them, but we can see the newest one that we just created is called DevNet 1722. So it's already there in the UI for me to interact with. So now we have created the ID. We want to say that anyone in the Brewing Co. environment can speak to that Google DNS. So we want to kind of build that policy line programmatically as well. And to do that, we're going to use the applications endpoint. So if I pop over to the application and securities policies, and the piece that I'm most interested in is policies. So I want to create a policy. It's going to have a action, so is that allow or deny, and it's going to be between two different groups of endpoints. So I'm going to copy that one. So we have v0. It is an allow. We'll give it a priority of 110. The consumer filter ID is the brewing co, which is and actually and we need to give it the ID of our application. So we can get the ID of our application by coming to the UI, and we can grab that from the URL. Which and then the next thing we need to do is just say we created DNS policy with ID policy. So, anyone see any mistakes? That was not a trick question. I could genuinely make mistakes. Everything looks good. We're going to create a policy in the first or the 0 version of this workspace. It's a default policy that's going to allow. The priority is 110. It's going to be from anyone inside my data center to the filter that we just created, which is that Google DNS entity. And it's going to be from the OpenAPI. I can get rid of this bit. I don't need it. So it's going to select the application that we've been looking at, and it's going to post that up. And if it's OK, we'll get the ID. So that looks good. If we refresh our page, looking good. We've got the new policy here that's allowing priority 110 from Brewing Co. to the Google DNS. But you can see right now that the policy is inactive because we haven't actually specified the ports and protocols that we want to open between those two different groups. So let's go allow port 53 UDP between the Brewing Co. server and the DNS client. So if we come to policies and go a little bit further down, we can add some service ports to the policy. So I'm going to need to add a version, start port, end port, and protocol. OK, who remembers the protocol ID for UDP? This is a question. What was that? 53 is the port number, indeed. And end port. And I believe it's, make sure that we get this right, 17 is the assigned protocol ID for UDP. So we're going to take this payload. We're going to post it to the policies, the policy ID, which we had earlier. I think our policy ID was 1A5, so we'll put that up there. One more time, we'll check that looks good. Version v0, protocol 17, start port, end port 53, and we'll post to the app layer 4 parameters. Oh, that should be policy. No one caught me there. And with one more stroke of luck, we have UDP 53 DNS in the policy there. So the final thing that we need to do to really kick this off is we're going to want to enforce this policy. So right now, enforcement is disabled for this application. And we would need to click this green button to enforce the policy. And as you would expect, we have an API call to do so. Now, enforcing the policy is at an application level. So I just need to take this API call. So our app ID, which is, and we're going to have our payload just to be the application ID as well. I think that was correct. All right. So we just simply call the API to enable policy enforcement, and if that's okay, we're going to start pushing those policies down to the endpoints and enforcing that policy in the hosts. Now, that's reached the end of our little demonstration of adding the policy to the workspace. And before I actually start enabling the policy enforcement, I'm going to hand it over to Remy, who's going to write a script to actually listen to the dynamic changes to the policy. And then once he's set that up and he's listening to the changes in the policy, we can call this script one more time and see on his laptop the policies being pushed down to the endpoints. So I will take a seat. Have fun.
Please take a seat. Okay, so hi everyone, my name is Remy. I do the same thing as Tim. I just happen to prefer Go than Python, so we decided to split the session Go versus Python. Why? Because Go can be compiled, and if you want to share a file with someone, no need to install Python, no need to install anything, it just works. That's the only reason. So we've done a few things here. So Tim has defined a policy that he has not yet enforced. And, well, a policy, that's nice, but you might want to enforce it somewhere else than on a server. Maybe you want to go on some third-party firewalls, something that is not Cisco. God forbids, but why not? So if that was the case, we actually created a framework to get out the policies of Tetration over the Kafka interface. So it's actually really simple to use. There we go. So when you log in inside Tetration, I'm back on the same tenant as Tim was using earlier. So our famous brewing company. And if I go to the maintenance section here in Data Platform Admin, I have all the configuration related to Kafka. And inside the configuration of Kafka, some things are actually pre-configured for me. One being the data tab that will send you the policy. So you have one here. It's available on every single system you have, and you're going to have one of those per tenant. So if you decide to build a platform multi-tenant, you can ingest the streams individually for the policy of Brewingco or some fancy stuff. Or I think we have Sushiko, Sushiko, where we have all the various companies that we run internally that use this. Everything that we're doing is contained to this environment. And so using Kafka is actually fairly simple. You see here IP addresses and so on. The only thing you have to do is hit download, select your file format. Do you want to use Java or do you want to use something else? If you want a Java key store, you just select it. In our case, as we're not using Java, we just take the normal one. Hit download. It's going to download a zip file with all the certificates inside it, which are here. Used to be able to zoom in, but not anymore. Okay. So this file is going to have a few files inside it. One is going to have all the list of IP addresses you want to use. Those are all the brokers running on top of Tetration. So if you're familiar with Kafka, Kafka has a broker. It can have multiple brokers. This way you can share the load, handle redundancy, and all the stuff around that. One is going to be the CA cert, so the certificate of Tetration that will allow you to basically validate the identity of the receiving. And then we're going to issue a certificate and a private key for authentication authorization across the platform. Finally, you'll have one file which is going to show you which topic you have to listen to in order to see the traffic. So you see, not very complex. You don't need to go through all the fun of building your own Kafka receiver, broker, etc., etc. Now to get this running, just like with Python, we didn't build anything. GitHub. We haven't built anything as fancy as Tem, but we have a client on GitHub that actually is available for you. This client, you have all the docs here. So this is a public GitHub, by the way. So it's not internal Cisco or anything. You just have a thing. How do you build it? How do you configure it? So very basic. How do you run it? And finally, what kind of output you can expect from the policy. So nice outputs, fairly useless at this point because, I mean, who's going to read this to go and design something across the environment? So in order to do this, let's take let's build an app that's going to do something a little bit different. It's going to take the policy stream from Tetration, and it's going to create a JSON file that has the policy, the intent, who are the clients, who are the servers, what is the action. This way you can very simply allow deny traffic between sets of IP addresses in the environment. So to do that, where is my window? Here we go. Big enough? Yes. Let's go to our main file. And I'll go down directly where everything starts. First thing, we're going to initialize a new Kafka config. All that is part of the template, by the way, so it's not something that you have to rewrite or anything like that. Everything in this file, on the main file, is part of the template. Anything in the policy.go file is what I added. So you see it's very easy to handle. You take the topics and so on, which are set in the config file, which is here, the config.toml file. It has everything set inside it. And it's going to set up all the Kafka plumbing and everything you need to get started. So again, there is an option, I'll put you here. If you do not want to code in Go, that's a possibility. Then what you can do is actually take the a Unix socket, which will actually pipe the protobuf from Go, from Kafka, down to whatever language you want to use after. Would be JavaScript, do JavaScript if you don't want to build your own Kafka environments. That's your call. If you want to get that running, you just need to set enable equals true, and you put the location of the socket. All the traffic will pass through. So now, all this is set for me. The only real important line in here is process update. Anytime Tetration is going to generate an update, it's going to throw this update over Kafka. It's going to fall in one of the partitions. is going to travel through this thing. We're going to receive it. So we're going to sit there listening for this traffic to come back to us. These are the actions that we're actually going to trigger. So first thing, we want to show that we're processing an update. Why? Just because debugging makes life a bit easier like that. We are going to take the network policy out of the Tetration environment, and we're going to process it. Once it's processed, we'll convert it to a JSON file. So that's what we added now. We did a few things. We did, so those ones considered, who's familiar with Go here? No one? You're lying. So the logic of Go, you have to declare your type. So it's not C or Java, like hard typed like that, but you still have to declare a type. So those would be equivalent to C structures, if you're familiar with C, that you are going to be reused. Technically, that's not more than just a JSON array. That's really how you can see it. So that defines all types that can then be converted to JSON. If you want the longer, more complex explanation, there's good docs online. So I'm going to define an intent, which is taking a provider and a consumer and an action. I'm going to define an inventory filter, which basically specifies the sets of IP address which are there. And I'm going to define a policy that takes everything and just merges it together. Then my first step, remember here, I'm processing policy. So I can go back to process policy. I take all the network policies. This is given to you, by the way. It's a protobuf file, so you can do whatever language you want from that. That's why, hence the Python pipe, if you want to do that. It's going to range through all the policies, process the inventory items, process the intents, and then append the generated policies to an array that we're going to return after, which is going to be used to convert to JSON. First part, process inventory items. When Tetration is going to send out updates for you, it's going to send quite a bit of data. It's going to send whatever query you're using. So whatever Tim has defined as a query is going to be converted to text, and you can take it out here. You're going to have an ID because we need a unique key, obviously, to refer to them, a name, all that stuff. And then we're going to look at all the members for a policy. As we range through the members, we're going to start looking for some data. So first of all, the type of the address. Is this address an IP range? Is it a subnet? Is it a host? Is it IPv4? Is it IPv6? All that's kind of good stuff here. So what we do here, we use the reflection to detect the type of the structure in it. And we can see that this is an address range, for example, in that case of the switch. We get the range. We get the first IP, the last IP, and we just append them because they're IPv4 and because Mark is not there. We don't believe in IPv6, so everything is fine. Once we've done that, we do the same thing for if the inventory type is an IP address. And then we're going to basically go and get the inventory filter for this filter, and we're going to append that to a map. Why a map? It's just easier to search through a map than it is to process an array. That's all. Faster. Once we've done this, we're going to look at intents. Because if you think about the order, I have a network policy that has members and filters, but intents are going to refer to members and filters. So you want to start by the members and filters before you actually process the intent. As you do this, see, this one is really no rocket science at all. I'm just basically going to populate my structure with the data I've already set before, including get the action, allow, deny of the environment. And once we've done all that, we're just going to make it a JSON file. I mean, that's all it does. There's nothing else. So, with that being said, The code will be available on GitHub as well on the Tetration-Exchange repo as usual. I don't think we pushed it yet, did we? No. So here are my files. Again, the only file I added from the template is the policy.go file. So we're going to do two things actually. Let's build it because we want a nice binary. This way I can take the binary, I can give it to Tim, I can give it to whoever you want as long as they have a Mac, or I can cross-build for some other platform. And we can run our DevNet 1722. What happens at this point? That this program is just sitting idle, waiting for a message to come through from Kafka. So it's just going to wait and wait and wait until someone does something. Which means that, could you do something, Tim? Because I can try using your password, but...
I would never give it. Okay, so I'm going to finish off, and we're going to push the policies down. So if we look here, our application still is not enforcing the policy. So all we need to do is run that once. And in the UI, we can see policies have been enabled. So we're now allowing traffic from our tenant to Google DNS on UDP port 53. And that's going to now generate a message via that Kafka stream to Remy's application. So if we switch back to this one, it's a variable time range between 30 seconds to about 2 minutes before you will see the update come through, just depending on the luck.
Network related as well. So there are a few things as well, obviously. Here, you notice the network is a little bit sketchy, just a bit. So if that's the case, we have to wait until it continues retrying and getting the data. But it's going to come, hopefully. There we go.
There we go.
So that's the policy Tim has just enforced, which has been set, which is being resent because obviously there is probably a bit of packet loss happening in this environment. And if we look at something to make it nice, because console is never very nice. We have a policy that has been generated now that's easy to take out and to push somewhere else across the environment. That's going to render quite a bit of things. So the Google DNS of Tim, and it's also going to render things like we have Kubernetes running in the backend for a completely different session. So you can see it's actually allowing the traffic that you allowed at the top from Brewing Co to Brewing Co, which is the only endpoint that's available in there. Does that make sense? We lost everyone? No? Good. So now, should Tim decide to stop enforcement? The reason why you see lots of message is that every single time there's a movement of IP inside the environment, it's going to generate a new update. So in this case, containers get spin up, spin down, they change in the environment. All this is happening as we're speaking. And then don't press enter, because that's the exit. So at this point, all those things are going to happen in the back end of the platform. So now, within hopefully a few seconds, let's see how many times we get the update this time. We should see the magic message coming in, which is we're done. Yes, no, maybe. Come on.
Our poor cluster all the way over in San Jose.
See, that's the typical French guy, always complaining it's broken. And there it is. Broken. And that's what you see. The last message here is actually the catch-all is reset to allowed because obviously we disabled the firewall. The list of my intents is now empty because I don't have anything I want to put in there anymore. So that's how you can use the policy in Tetration with something else, whatever. So now you can see how easy it is to adapt this framework to something. We gave you this example related to policy because everyone's talking about policy, but alerts are sent under the same format. So if you want, what was that? If you want, you can also collect alerts from Tetration because something has changed in your environment. In the same way, process them, do something with them. Any questions?
I don't have any questions.
You don't have any questions? Anyone has any questions? No? Okay, then I think we're done.
Thank you very much.
Thank you.